Friends, in this video we are showing you how to do sampling for RSPM or PM10 and gaseous pollutants using Respirable Dust Sampler. Respirable Dust Sampler has a rugged, compact and easy to transport anodized aluminum body, very ideal for field use. It consists of an air inlet cap, an air inlet pipe, a cyclone and a dust collection cup attached at the bottom of the cyclone. In this instrument, separation of coarse dust and fine dust is done with the help of a cyclonic separation technique, and cyclone design is very critical. A glass manometer which measures the sampling flow rate of air directly in cubic meters per minute. Some instruments provide pressure values on the manometer. These are not very convenient to use because in that case one has to refer to a conversion chart for converting pressure values to flow rate values. Instrument has one-time totalizer to record the sampling period. Timer is used for programming the sampling schedule. One can program the start and stop time of a sample and the instrument will automatically start and stop at the preset time. Instrument has an automatic flow controller which ensures constant flow rate and terminates the sampling if flow rate drops below 0.85 cubic meter per minute. There is the switch for setting the flow rate in the desired range. There is an auto manual switch to set the instrument in auto mode. Reset button is used when the instrument stops on its own. One can restart the instrument by this push-pull button. There is an on-off switch to start and stop the instrument. There is one pump indicator which shows that the pump is on if this light is glowing. There is one heavy-duty motor and blower, which is almost noiseless. Now we will tell you the preparations we should do before starting the monitoring. What items we should have with us. Data sheets. Filter papers. Reagents or absorbing solutions for gases. Sample bottles. Glass impingers. Please see that amber color impinge is used for ozone sampling. Distilled water bottle. Electric extension board. Icebox and tool kit. Tool kit consists of 1 mains cord. For dust collection, cups with lids. A screw driver set. Silicone grease. 1 wash bottle. 1 reverse cord for 411 TE. 1 syringe. 1 brush for cleaning cyclone cup. 2 fuses of 0.5 ampere. 2 fuses of 2 ampere. 3 Allen keys. And silica gel drying tubes for 411 TE. Here, we are showing you how to set the timer. First of all, set the clock. For this, press the key, written clock and hold it, set day, by pressing day key. Then set time in hours with hour key and set minutes, by minute key. Now release the clock key. You will see the actual day and time on the screen. Now, let us set the start time of the sample. For this, press the timer key, screen will show 1 on. It means, this is program number 1 and on means, it is the time to start the sampler and then set day, hours and minutes from the respective keys as before. Now, your start time is set. Now, again press the timer key, the screen will show 1 off. It means, you are to set the sample termination time of program 1. Set day, hours and minutes from the respective keys and your instrument will automatically shut down on the set day at the set time. Now, again press the clock key, the screen will show the actual time. Next step is to move the cursor with the manual key to auto position and put the on-off switch in on position. The instrument will automatically start and stop at the time you have set. If you want to start and stop the instrument manually, then move the cursor to on position with the manual key. There are 3 positions, on, auto and off. If you move the cursor to of position, the instrument will not start at all. So please, be careful and keep the cursor either on the on position or on the auto position only. Information to be noted down on the data sheet before starting the sampling are: location of monitoring. Instrument serial number. Filter paper number. Sample start date. Sample start time and initial weight of the filter paper. Now, let us start the sampling for PM10. First, check whether the power supply is having proper earthing. Proper earthing protects the instrument components from electrical damage. Connect the instrument to 220-volt power supply with the help of a power cord. Check that the dust collection cup is empty and clean. O-rings on the bottom of the cyclone are in good condition and the dust collection cup is securely placed. Now, record the initial time totalizer reading on the data sheet. Now, check for water level in the manometer. It should be at 0. If water level is not at 0, make it at 0 by adding or removing distilled water to it. Add water with the help of a syringe after removing this manometer filling plug and replace it after adjusting the water level at 0. Check the O-ring fixed over the manometer filling plug is not damaged. Replace with a new one, if required. Next step is installation of filter paper. Filter paper of size 8 by 10 inch of Wattman or any other make is used. Check each filter paper against the sun or light for any pinhole, etc. Please note that one side of the filter paper is somewhat smoother than the other side. Number each filter paper on the smoother side, desiccate it for 24 hours, and then take their initial weights on a suitable weighing balance. Carry them in a box, preferably in the same filter paper box. Unscrew the 4 wing nuts and open the top cover, set it to stand like this. Place the filter paper carefully and the smoother side of the filter paper should face the wire mesh. It should be exactly in the center of the wire mesh. Hold it at its position and switch on the instrument with this on-off switch. Filter paper will stick with the wire mesh due to air suction through it, and now replace the top cover and tighten all 4 wing nuts. Tighten the diagonally opposite wing nuts one by one and gradually, and then switch off the instrument. Gaseous pollutants can also be sampled along with the particulate sampling by attaching a gaseous attachment. Gaseous attachment consists of an impinger tray for placing up to 4 glass impingers of 35 milliliters capacity and is thermoelectrically cooled, which keeps the temperature of absorbing media around 15 degrees. A gas manifold for adjusting the air flow rate of different impingers. 4 silica gel tubes contain dried silica gel which absorbs the moisture of the air leaving the impingers after bubbling through absorption media, protecting the manifold valves and help in maintaining the set flow rate. A rotometer of 0 to 3 lpm for measuring the flow rate and a silicon tube attached at the outlet of the rotometer. Now, place required quantities of absorbing media in each of the glass impingers, label them and place in the tray. Now, let us attach the gaseous attachment 411 TE to the respirable dust sampler. First of all, connect the silicon tube attached at the gas manifold with the air inlet provided at the RDS. Now, remove the 2 nuts and attach the gaseous attachment on the 2 bolts. Replace the nuts and tighten them firmly. And start the sampling by switching on the instrument and setting the flow rate with the help of flow setting valve. Allow the instrument to run for a few seconds to stabilize the manometer reading and note down the initial manometer reading on the data sheet. Next step is to set the sampling flow rates for gases by connecting the rotometer to individual impingers and adjusting the required flow rate through the gas manifold. With the help of a screwdriver, and note down the initial flow rates of each gas on the data sheet. It can be in the same data sheet or a separate data sheet can be made for gaseous pollutants. Now, let the sample run for the required time duration like 4 hours, 8 hours, 12 hours or 24 hours. Sampler will stop automatically at the preset time if sample stop time was preset. For noting down the final flow rate readings, again switch on the instrument and let it run for a few seconds and then note down the final flow rate readings of RDS and each of the impingers. In case shutdown time was not preset, take final readings of the flow rates for RDS and each of the impingers by putting this tube to each of the impingers and then switch off the instrument. Now, note down the final time totalizer reading on the data sheet. Also note down any special weather conditions persisted during sampling like thunderstorm, rainfall and amp, cloudy weather, etc. It helps in interpretation of data. Remove the filter paper very carefully by unscrewing the wing nuts. Filter paper will look like this after sampling. Initially it was white in color and now it has become quite dark due to dust deposited over it. 4. Fold the filter paper keeping the exposed side inward and carefully keep it in a labeled envelope. Transfer the absorbing media in labeled plastic sample bottles. If there is any evaporation loss in the absorbing solutions, make it up with distilled water. Store the filter paper carefully in an envelope and send gaseous samples for analysis to the laboratory in an icebox. Take final weight of filter paper after proper desiccation and calculate the results of RSPM or PM10 from the weight of dust collected on the filter paper and the volume of air sampled as below. Let initial weight of filter paper is W1 gram. Initial time totalizer reading is T1 hours. Initial flow rate is F1 cubic meter per minute. Final time totalizer reading is T2 hours. Final flow rate is F2 cubic meter per minute. Final weight of filter paper is W2 gram. Dust collected on filter paper equals difference of final weight of filter paper and initial weight of filter paper in grams, that is W2 minus W1. Average flow rate in cubic meter per minute equals sum of initial flow rate and final flow rate divided by 2, that is F1 plus F2 by 2. Total time of sampling in hours equals difference of final time totalizer reading and initial time totalizer reading, that is T2 minus T1. Then, sampling time in minutes equals total time of sampling in hour multiplied by 60. Total sampled volume of air in cubic meter equals sampling time in minutes multiplied by average flow rate cubic meter per minute. PM10 concentration in grams per cubic meter is given by the ratio of dust collected on filter paper in grams and total sampled volume of air in cubic meter. Then, PM10 concentration in micrograms per cubic meter equals PM10 concentration in grams per cubic meter multiplied by 10 raised to the power 6 equals W2 minus W1 multiplied by 10 raised to the power 6 divided by the product of F1 plus F2 by 2 and T2 minus T1 into 60. If one is interested in the assessment of TSPM also, then the weight of coarse dust collected in the dust collection cup is also considered along with the weight of dust collected on the filter paper. Weight of coarse dust is obtained from the difference of final weight and initial weight of dust collection cup and its lid. Detailed methods for measurement of RSPM, PM10, are also described in Envirotech Manual for Sampling Dust and Gaseous Pollutants, Volume 1 and 2. IS 5182, Part 23, 2006. CPCB Guidelines for the Measurement of Ambient Air Pollutants, Volume 1. Hope this has helped you in understanding the sampling for RSPM or PM10 and gaseous pollutants using a respirable dust sampler. Thank you.